Stop listening to the dealership hype because they are robbing you blind under the guise of certified hybrid care. The automotive industry has successfully brainwashed millions of drivers into believing that a failing hybrid battery requires a $4,000, $0 to $6,000 complete replacement. But our workshop data proves that 85% of the time, only 2 or 3 individual modules have actually degraded. Dealerships upsell what you never needed, pocketing massive margins on massive battery crates, while a targeted $50 cell replacement could have completely restored the pack's equilibrium. Most drivers think that a hybrid system is an untouchable, futuristic black box that requires advanced engineering degrees to touch. But here is what the service counter advisors don't tell you. Toyota's legendary reliability is built on simple, modular blocks that can be serviced individually with basic tools. And a bit of real-world mechanical knowledge. Let's uncover what they don't want you to use. Your own brain and independent specialists who understand voltage balancing. A customer came in with a 2015 Prius throwing the dreaded hybrid system failure code, facing a dealer estimate that exceeded the actual resale value of the entire vehicle. We hooked it up to our diagnostic software and found that out of the 28 individual modules inside that high-voltage pack, 26 of them were completely healthy and holding a perfect charge. The dealer wanted to scrap a massive, perfectly functional piece of machinery just because a single weak link was dragging down the total voltage line. That full battery replacement only happens because service departments prioritize corporate turnover over genuine diagnostic repair. The illusion of the monolithic battery pack. The entire industry relies on your ignorance to keep their service bays profitable year after year. When you look at the marketing brochures or listen to the smooth-talking sales reps, they frame the hybrid battery as one giant, irreplaceable powertrain component. That is a calculated lie designed to manufacture compliance when the warranty expires after 10 years. In reality, inside that metal casing sits a sequence of low-voltage modules working together like a bucket brigade. If one person in the line gets tired, the whole line slows down, but you do not fire the entire workforce. You replace the single worker. Module 2, failed module 3, module 4, module 28. Doll. Only this $50 cell needs replacement. The modular truth. Most standard Toyota hybrids utilize 28 individual modules linked in series. The voltage reality. Each module runs a specific voltage, and the vehicle computer monitors variance down to the millivolt, the diagnostic trap. A variance of just 1.2 volts between modules will trigger a master dashboard warning, causing dealerships to condemn the entire unit. The corporate playbook dictates that technicians must never open the battery casing to service internal components. They claim it is a matter of safety, but it is actually a matter of guaranteed revenue generation. By enforcing a strict replacement-only policy, manufacturers ensure that independent repair shops are cut out of the loop and consumers are forced to buy brand new inventory. Honest mechanic truth. Dealerships do not repair cars anymore. They are parts changers who swap entire systems at your expense because they lack the training or the permission to fix individual components. Reconditioning versus patching. The financial reality. Most owners don't realize that there is a massive difference between a temporary patch job and a true battery reconditioning process. You can jump online right now and find thousands of forum posts advising you to just buy a cheap used module on an auction site, slap it into the pack, and call it a day. That is a dangerous half-truth that will land your car right back on the flatbed tow truck within 3 months. When you introduce a random module into an aging pack, the voltage imbalances will cause the surrounding cells to work twice as hard to compensate. Unnuts plus. Hybrid repair operations. +% method. Real cost, lifespan expect. Dealer replacement. $4,500, $6,000. 8-10 years. Proper reconditioning. 1,200, 1,800, 3-5 years. Single cell patch. $150, $300. 2-6 months. Plus prestent trice plus prestent plus presente. True conditioning requires deep cycling the entire pack using specialized equipment to break down crystalline memory formations within the cells. We charge a fraction of the dealer price for this service because the raw materials cost us nothing but time and electricity. You can save thousands of dollars by seeking out specialized hybrid shops that perform full-pack equalization rather than letting a franchise dealer guilt you into a finance plan for a brand new battery. The system is designed to trigger warnings early, giving you ample time to find an alternative to the corporate service counter extortion. The secret killers of hybrid longevity. The EPA says optimal driving habits preserve hybrid efficiency. But real-world wear proves that environmental neglect costs owners hundreds of dollars in premature degradation. The greatest enemy of your high-voltage system isn't mileage or age. It is thermal stress and stagnation. I see pristine, low-mileage Toyota hybrids towed into the shop with completely dead batteries because the owners thought they were preserving the vehicle by letting it sit in a garage for weeks at a time. A nickel-metal hydride battery demands regular chemical exercise to maintain its capacity. Thermal suffocation. The hybrid battery cooling fan draws air directly from the passenger cabin, usually through a small vent next to the rear seats. Debris accumulation, dog hair, dust, and lint clog the internal fan blades over time, reducing airflow by up to 40%. The heat spike without sufficient airflow. Internal temperatures skyrocket past 55 degrees Celsius during highway driving, accelerating chemical breakdown. Rear seat cabin vent dust, hair clog, restricted fan, overheated battery pack. When that fan gets blocked, the battery cooks itself from the inside out while the vehicle dashboard remains completely silent until the damage is already permanent. You can clean that cooling fan yourself in under 20 minutes with basic hand tools, yet dealerships will never mention this preventative maintenance task during your routine oil changes. They want that battery to degrade because a dead pack means a massive payday for their service department. Honest mechanic truth. Leaving a hybrid vehicle parked for a month does more irreversible damage to the high-voltage cells than driving it 50,000 kilometers straight through stop-and-go city traffic. When does a full replacement actually make sense? We must look closely at math before making a definitive decision on whether to repair or replace the entire high-voltage assembly. If your vehicle is a 15-year-old Prius with a market value of $4,000, handing over $4,500 to a service advisor for a brand new battery pack is an act of financial self-sabotage. However, if you plan on keeping the vehicle for another decade, or if the individual internal modules show uniform degradation across the board, patching becomes a losing game. All the cells inside that metal box age under the exact same thermal conditions, meaning that when one cell drops below the threshold, the others are sitting on the edge of the cliff. Model voltages 7.2V, 7V, 6.4V, 7.2V, 7V1 failed, but the rest are already borderline. If you choose a cheap patch repair on a completely exhausted pack, you will find yourself paying for labor over and over again, as each subsequent module fails one by one every few thousand kilometers. You must demand a full diagnostic report showing the internal resistance and voltage variance of every single block before approving any repair work. If the variance between the highest and lowest module exceeds 0.3 volts across the entire pack, individual patching is a temporary band-aid that will fail you when you need it most. But that is only the beginning of the deception. There is one specific maintenance item that every single hybrid owner completely overlooks. A silent killer that destroys the inverter system before the battery even has a chance to wear out. That silent killer draining your wallet is the catastrophic failure of the high-voltage inverter assembly, triggered entirely by an easily preventable thermal overload that dealerships deliberately ignore during your routine service visits. While service advisors keep your attention focused exclusively on the high-voltage battery pack, the inverter is the actual brain of the entire powertrain, responsible for converting direct current into alternating current to drive the electric motors. If this component overheats, it doesn't just degrade, it fries itself instantly, leaving you with an immediate $3,000 repair bill that could have been completely avoided with 15 minutes of labor and $20 worth of fluid. Let's uncover what they don't want you to know about your Toyota's dual-loop cooling system. A customer came into the workshop last month after their Camry hybrid suddenly died on the highway, displaying a catastrophic check hybrid system warning and a completely unresponsive throttle pedal. The dealership had already quoted them for an entirely new inverter module, claiming the system had simply reached the end of its natural operational life. When we pressure tested the system, we discovered that the independent inverter cooling loop was completely choked with calcified silicate deposits, reducing fluid velocity by a massive 65% and instantly cooking the intelligent power modules inside. The dual-loop deception. What your owner's manual hides the entire automotive service industry relies on the fact that the average driver doesn't understand what happens under the hood of an electrified vehicle. Most owners assume their car has one radiator, one water pump, and one cooling system that manages everything from the engine block to the cabin heater. Toyota engineers actually designed these vehicles with two completely separate, isolated cooling loops that never mix fluids. One loop manages the internal combustion engine, while the second, highly critical loop regulates the massive heat generated by the inverter and converter assembly. 1. Plus Toyota Dual Loop Cooling System plus Donuts plus Engine Block, Engine Radiator, Loop 1. Inverter Assembly, Inverter Radiator, Loop 2. Plus Dunderin plus the engine loop. Runs at high temperatures, around 90 degrees Celsius to 105 degrees. To keep the gas engine operating efficiently, the inverter loop must run significantly cooler, below 65 degrees Celsius, to protect the delicate silicon-controlled rectifiers and insulated gate bipolar transistors, IGBTs. The maintenance gap, dealership service menus bundle coolant flushes into a single charge. But technicians routinely skip the inverter loop because it requires a dedicated electronic bleeding procedure. When you pay for a generic fluid service at a standard shop or a negligent dealership, they drain and refill the engine radiator because it is easily accessible right at the front of the engine bay. The inverter reservoir sits tucked away, often requiring the removal of structural plastic clips or trim panels, so it gets ignored until the fluid turns acidic and destroys the internal aluminum heat exchangers. Honest mechanic truth. If your service invoice doesn't explicitly list two separate line items for super long life coolant quantities, you paid full price for half a job, and your inverter is currently cooking itself alive to step-by-step restoration. Bleeding the inverter loop without dealer software. You do not need a $5,000 factory scan tool to flush, refill, and bleed the high-voltage inverter cooling system in your driveway. The dealership will tell you that handling this system poses an immediate electrocution hazard, but that is a scare tactic designed to keep you dependent on their service bays. As long as the vehicle's ignition is completely turned off, the internal relays isolate the high-voltage electricity inside the battery pack, making the inverter cooling loop as safe to work on as a standard windshield washer reservoir. Step 1. Locate drain plug. Step 2. Refill reservoir. Step 3. Trigger service mode. Step 4. Top off fluid. Step 1. Evacuate the degraded fluid. Locate the dedicated inverter drain plug on the transaxial assembly, which is distinct from the engine oil or transmission drain plugs. Place a clean catch pan underneath, remove the hex plug, and let the old fluid drain completely. You will know the fluid is severely degraded if it has turned from its original vibrant pink color to a dull, hazy orange, or contains visible floating particulate matter. Step 2. Inspect the inverter reservoir filter screen before pouring a single drop of new fluid into the system. Unclip the plastic reservoir tank and inspect the micromesh filter screen located at the bottom of the feed port. Our workshop data shows that 40% of hybrid thermal failures are caused by this tiny screen becoming completely blinded by plastic flashing debris left over from the manufacturing process. Clean the screen thoroughly with pressurized brake cleaner until light passes through it perfectly. Step 3. Execute the manual bleeding sequence. Refill the reservoir to the max line using only genuine Toyota super long life, pre-diluted coolant. Never use generic green fluid or tap water, which introduces minerals that instantly short-circuit the internal isolation barriers. To bleed the air out without a scan tool, perform the following sequence exactly. Insert the key or bring the fob into the cabin, Without pressing the brake pedal, press the power button twice to enter IGI on mode within 15 seconds. Depress the accelerator pedal fully 2 times. Shift the vehicle into neutral, then depress the accelerator pedal fully 2 times. Shift the vehicle back into park. Then depress the accelerator pedal fully 2 times. Press the brake pedal and press the power button one final time. This specific diagnostic sequence forces the vehicle into maintenance mode, which bypasses the hybrid computer's cycling logic and forces the electric inverter water pump to run continuously at 100% duty cycle. Step 4. Purge the air pockets. Watch the inverter reservoir closely. While the pump is screaming, you will see a massive geyser of air bubbles escaping through the fluid. If you leave these air pockets inside, they will trap heat against the electronics, causing a localized thermal spike that melts the internal circuitry. Keep adding fluid to the reservoir as the level drops until the fluid surface runs completely smooth with 0 bubbles for 5 consecutive minutes. Data proof. The real value of preventive thermal management data collected across thousands of independent hybrid service records proves that maintaining an inverter temperature drop of just 5 degrees Celsius extends the operational lifespan of the entire front transaxle by more than 150,000 kilometers. Electronic components degrade exponentially when exposed to heat cycles that cross their maximum designed thermal threshold. Ren plus. Inverter temperature, vs. Felsher rate, plus Dudrin plus. 50 degrees Celsius, fresh coolant, minimal wear. 61 degrees 70 degrees Celsius, accelerated aging. 71 degrees Celsius plus, air pockets, fatal jump. Plus Dunderen plus. When fluid breaks down, its chemical properties shift from a protective rust inhibitor to an electrolytic conductor. The old fluid begins to slowly eat away at the internal aluminum cooling passages inside the inverter box, creating microscopic pits that eventually allow high voltage current to leak directly into the low voltage ground circuit of the car once that internal isolation fault occurs. The vehicle's main computer instantly shuts down the entire hybrid system to prevent a vehicle fire, permanently destroying the inverter module. A $20 jug of correct coolant completely prevents this molecular breakdown from ever initiating. Honest mechanic truth, the vehicle manufacturer states this fluid lasts 160,000 kilometers. But real-world testing shows that chemical additives degrade after just 80,000 kilometers, leaving your most expensive electrical component completely unprotected. Exposing the electronic water pump scam. The second half of this hidden crisis involves the electric water pump that drives the inverter cooling loop. Unlike a traditional gas-powered car that uses a mechanical water pump driven by a rubber belt, your hybrid uses a completely brushless DC electric pump controlled by a microprocessor. When these pumps begin to fail, they don't leak fluid or make a loud squealing noise to warn you. They simply slow down or stop spinning entirely without throwing a dashboard code until the system has already overheated. Normal flow, 12 liters, degraded pump flow. 4 liters, silent inverter cookout. Dealerships love this failure mode because they can charge you $800 for a new pump plus 3 hours of diagnostic labor. You can verify the health of your electric pump yourself in 10 seconds without unbolting a single component. Open the hood while the car is in ready mode, look directly at the inverter fluid reservoir, and check for active fluid movement. If you don't see an aggressive, swirling vortex of pink fluid inside that tank, your electric pump's internal impeller is either completely bound up with debris or the electrical windings have shorted out. Replacing this pump requires removing exactly 3 10mm bolts and 1 electrical connector, a task that takes less than 15 minutes on a driveway, but brings in massive profits for corporate service centers. But that is only the beginning of the conversion process. There is a secondary, completely hidden software calibration loop within the vehicle's central gateway module that actively throttles your hybrid's battery recovery system as the vehicle crosses specific mileage milestones. That hidden calibration loop is a digital kill switch that systematically strangles your high-voltage battery's capacity based on arbitrary mileage counters rather than actual physical degradation. While you are busy cleaning physical filters and flushing cooling lines. The vehicle's engine control module, ECM, and battery smart unit are running background algorithms designed to artificially limit your state of charge window as the car gets older. Manufacturers write this software under the guise of battery preservation, but our workshop diagnostics show that it deliberately robs you of up to 25% of your available electric-only driving range to force a premature upgrade. Let's uncover what the I don't want you to access. The internal Delta state memory registers that dictate how the vehicle utilizes its storage cells. A vehicle came into our shop running completely fine, but its fuel economy had plummeted from its historical average of 4.5 liters per 100 kilometers down to a dismal 6.2 liters, with the gas engine kicking on almost instantly after pulling away from a stoplight. The owner had been told by 2 different corporate service departments that their battery pack was simply tired and needed a full replacement. When we forced a hardware reset on the battery monitoring parameters, the car immediately recovered its original electric capacity, proving the physical cells were completely fine while the software was lying to the dashboard. The battery state of charge, SOC, soft cap sabotage. To understand how to bypass this digital bottleneck, you have to understand how a Toyota hybrid manages its internal energy. The system is designed to never let the high-voltage battery charge to a true 100% or discharge to a true 0%. Instead, it operates within a tight, protected sweet spot, typically between 40% and 80% state of charge, to prevent the chemical stress that destroys nickel metal hydride or lithium-ion cells. Percent true capacity, 40% low threshold, window 80% high threshold, blow, 100% true capacity. DASC, factory software, gradually shrinks this window over time. The factory window, brand new. The car utilizes roughly 40% of the battery's true total volume to balance longevity and fuel efficiency. The aging algorithm, as the odometer climbs past 150,000 kilometers. The computer automatically shifts the operational limits inward, narrowing the usable window to just 25% or 30%. The fake degradation, the car spends less time in electric mode and more time burning gasoline, convincing you that the hardware has physically failed when it is actually just locked in a digital straitjacket. The service department will run a health check that relies on these exact same software-throttled parameters to generate a fail, or R. E-Place recommended diagnostic sheet. They are using data generated by a biased algorithm to justify selling you a physical component you do not need. Honest mechanic truth. Car manufacturers are software companies now, and they use programmatic planned obsolescence to ensure that even the most reliable mechanical hardware has an artificial expiration date built into the code, step-by-step restoration. Recalibrating the hybrid battery control module, you can force the hybrid control module to drop its conservative bias and perform a real-world assessment of the physical cells without spending a single dollar at a dealership. This procedure clears the learned historical resistance values that the computer uses to justify shrinking your battery window, forcing the system to retest the actual voltage stability under maximum load conditions. Step 1. Deep discharging. Step 2. 12V auxiliary reset. Step 3. Forced equalization drive. Step 1. Execute a complete chemical drawdown. Drive the vehicle to an open, level location like an empty parking lot. Place the car in ready mode. Turn the air conditioning system to its absolute lowest temperature. Turn the cabin fan speed to maximum and switch on the high beam headlights and rear window defroster. This creates a massive electrical draw on the high voltage system while the vehicle is stationary. Keep the car in reverse with your foot firmly on the brake pedal. This prevents the internal combustion engine from automatically firing up to recharge the pack on some models, allowing the high-voltage battery to drop to its lowest possible operational threshold until the dashboard battery icon shows a single flashing bar. Steeper 2. Perform the hard memory dissipation. Turn the vehicle completely off and open the rear hatch or side panel to access the small 12-volt auxiliary battery that powers the vehicle's computers. Disconnect the negative battery terminal completely using a 10mm wrench. Leave the terminal disconnected for a minimum of 30 minutes. Disconnect 12V negative terminal. Wait 30 minutes. clears ECM learned resistance tables. This temporary loss of power does not harm the vehicle, but it completely wipes the volatile memory cache inside the battery smart unit, destroying the historical degradation curves that the software used to restrict your state of charge window. Step 3. Trigger the relearning cycle. Reconnect the negative terminal and tighten it securely. Turn the vehicle on. You will notice the engine fires up immediately and runs at a higher idle speed than normal. This is the forced charging phase. Leave the car parked while the engine aggressively pumps current back into the high voltage pack until the internal combustion engine shuts off completely on its own. The computer is now measuring the internal resistance of the cells from a completely clean slate, mapping out a wide, restored operational window based on real-world capabilities rather than programmed mileage milestones. The 12-volt auxiliary battery connection crisis. Most owners don't realize that a huge portion of high-voltage battery fault codes have absolutely no thing to do with the big hybrid battery pack at all. They are caused entirely by a failing, neglected 12-volt auxiliary battery hidden away in the trunk or under the rear seat. Because a hybrid vehicle doesn't use a traditional starter motor to crank the engine, you will never hear that classic slow, grinding noise that indicates a dead battery in a normal car. The 12-volt battery on a hybrid has only one job. It boots up the main computer relays that engage the high-voltage system, Dundren, Dotteret, plus the voltage sensor error loop, plus Dudren and Darets, plus weak 12V battery vulnerary drops to 10.5 volts during boot. Computer panic sensor misreads main pack voltage, plus Dundruman, plus. When that 12-volt auxiliary battery drops below 11 volts during the initial boot sequence, the main hybrid computers suffer a momentary brownout. The analog to digital sensors inside the high-voltage pack misread the incoming data streams, panic, and instantly log a permanent master hybrid failure code on your dashboard. Dealerships will happily look at that code, ignore the weak 12-volt battery completely, and quote you for a full high-voltage system replacement. Always test the standing voltage of your auxiliary battery before allowing any mechanic to touch your hybrid system. If that small battery is over 5 years old, replacing it for $150 will instantly wipe out dozens of phantom hybrid system failures. The candid truth, tempering the hybrid hype now, let's get something completely straight, because I am not here to sell you a fantasy. While reconditioning software parameters and cleaning cooling ducts will absolutely save you thousands of dollars and extend your vehicle's lifespan, it will not make a worn-out chemical cell live forever. If your hybrid pack has spent 15 years in a scorching climate like Arizona, or has logged 400,000 kilometers of hard city driving, the internal nickel plates have physically warped, and the electrolyte paste has permanently dried up. No magic software reset or driveway flush can restore metal that has physically disintegrated inside a sealed plastic shell. Notterates plus. Realistic explanations after repair, plus Dudderuner, plus software reset gain, plus 15-20% efficiency. Fan cleaning gain, prolongs life 2-3 hours. Melted cell fix, percent physical damage unfixable, plus Dunrents, plus. My job is to stop you from throwing away perfectly good machinery based on a service advisor's greedy recommendation, but you have to use your own common sense. If your battery pack has multiple leaking modules or physical corrosion eating through the structural copper bus bars, a repair is a temporary band-aid that will leave you stranded on the highway. We apply these fixes to target the premature failures, the dirty filters, and the soft-coated electronic bottlenecks that the automotive industry uses to systematically drain your bank account. Honest mechanic truth: a hybrid vehicle is the most cost-effective tool on the planet for beating the high cost of fuel. But it only delivers on that financial promise if you treat it like an electronic appliance that requires clean ventilation and precise voltage balance, rather than an old iron engine that can be neglected until it breaks. Stop what you are doing right now, walk out to your vehicle, open the rear passenger door, and check that plastic battery air intake vent for blockages. If you find a layer of dust or pet fur covering that mesh screen, Clean it immediately before the internal thermal cycle initiates irreversible chemical breakdown inside your cells. The dealership wants you to leave that vent dirty because your ignorance is the single most profitable asset on their balance sheet. And taking control of your vehicle's maintenance is the only way to keep your money where it belongs.